In this lesson, we will use LabVIEW NXG to connect to non-NI instruments and validate the results. In this section, we will give an overview of an instrument control system. Suppose you have a standalone instrument from a non-NI vendor, such as Tektronix or Keysight Technologies. You can control and automate the instrument using LabVIEW NXG. LabVIEW NXG can automate instrument-based processes and consolidate multiple instruments into one development environment. A basic instrument control system consists of a non-NI instrument, hardware connectivity, and a computer. Instruments from non-NI vendors include amplifiers, analyzers, calibrators, oscilloscopes, power supplies, switches, function generators, and more. Hardware connectivity refers to the physical cable connecting the instrument and also the communication protocol or bus. Common bus types include GPIB, serial, USB, and Ethernet. Different buses have different capabilities for latency and bandwidth. Instruments often have multiple ports for hardware connectivity options. Finally, you can use LabVIEW NXG software on your computer to acquire, analyze, and visualize data from your instruments and to automate and control your instruments. Let's look at how LabVIEW NXG can help automate an instrument control application. Suppose you need to determine the cutoff frequency of an RC circuit by sending the RC circuit a frequency sweep of 100 different sine wave frequencies, 1 Hz to 100 Hz. To do this, you must input sine waves of frequencies between 1 Hz and 100 Hz to the RC circuit and analyze the output response signals. The function generator sends these stimulus signals to the RC circuit, and the oscilloscope acquires the RC circuit response signals. To do this manually, your steps might look something like this: long and involved, with a large amount of repetition and increased chance for human error. If you programmatically control your function generator and oscilloscope using LabVIEW NXG, you can automate many of these manual steps. This saves an enormous amount of time and decreases the chance for human error. Your steps would look something more like this. In this section, we will examine how to connect non-NI instruments to your computer. First, install LabVIEW NXG. Then install any required NI hardware drivers. You must install the NI VISA driver. If you are trying to communicate with a non-NI instrument using GPIB connectivity, then you must install the NI 488.2 driver, which automatically installs the NI VISA driver also. Next, connect the non-NI instrument to the computer. For example, if you are using a GPIB instrument, then you need a GPIB instrument control device on your computer, such as a USB GPIB HS device or PCI GPIB device. Connect the GPIB instrument control device to your computer and then use a GPIB cable to connect the GPIB instrument control device to your instruments. If you are using a serial instrument, then connect the serial port on your computer to the instrument with a serial cable. In this example, I have a 34411A digital multimeter instrument made by Agilent or Keysight. Looking at its rear panel, we see that this instrument has interfaces for a GPIB, USB, or Ethernet bus. For this example, I will connect this instrument to a GPIB cable. Now, I will attach this GPIB instrument control device to my computer. Now, I can connect my GPIB instrument to my computer. In this section, we will discuss how to communicate with a non-NI instrument and validate that you get the correct results. Launch LabVIEW NXG. After connecting your non-NI instrument to your computer, if you have a GPIB, serial, or Ethernet instrument, you will need to configure your instrument in NIMax. Launch NIMax. Now I'll walk you through how to configure a GPIB instrument in NIMax. Expand Devices and Interfaces. Click the GPIB instrument control device icon, and then click the Scan for Instruments button, which returns all GPIB instruments connected to your GPIB instrument control device. Notice that the default name for the instrument is based on a string containing the GPIB board number, primary address, and instrument. You can set a VISA alias for the instrument so you can identify the instrument more easily in LabVIEW. After configuring your instrument in NIMax, you will be able to see your instrument in LabVIEW NXG in the System Designer. Notice that your VISA alias for the instrument shows up here. Click this button for more information on how to configure serial, Ethernet, and USB instruments in NIMax. Next, you should find and install the specific instrument driver for your non-NI instrument. To do this, click on your instrument in the System Designer. Then click the Find and Install Drivers link. This will launch NI Package Manager and search for the instrument driver for your instrument. Follow the prompts to install the instrument driver. You can also search for instruments by vendor and model number. In this case, I've already installed the instrument driver for my instrument. Most instrument drivers include example programs that allow you to start communicating with the instrument right away, and also help you learn how to use the driver and provide a starting point for your own instrument control application. After installing an instrument driver, find its example programs in the Learning tab. In the Example section, under Hardware Input and Output, Instrument Drivers, and now we see our specific instruments examples here. Now I can select it and create a project containing the instrument's example programs. In the Project Files tab, I can select the example program that is closest to what I want to do with the instrument, and run it to validate that the instrument is returning the expected results. In this case, I am using my 34411A instrument to measure the resistance of a 100 ohm resistor with a tolerance of plus or minus 5%. So I'll set the VISA resource name to my 34411A GPIB instrument, and set the function to the measurement that I want to take, which is a 2-wire resistance. Now, I'll click the Run button to run this example program. It is now sending 5 software triggers to the instrument that acquire 10 samples each, and will return the measurement samples on this graph. And now, I've validated that the instrument is returning my expected result of 100 ohms plus or minus 5%. If no instrument driver exists for your non-NI instrument, you will need to communicate with the instrument using SCIPI commands. SCIPI stands for Standard Commands for Programmable Instrumentation. In this example, the computer sends a *IDN SCIPI command to the instrument, which asks the instrument to identify itself. The instrument responds to this command by returning a company name, model number, serial number, firmware revision, string. Refer to your instrument's manual to determine which SCIPI commands work with your instrument. To validate your instrument input or output results using SCIPI commands, click on your instrument and click the VISA Test Panel button. In the VISA Test Panel, go to Input Output and then enter your SCIPI command. The Write button writes the SCIPI command to the instrument. The Read button reads data from the instrument. The Query button writes the SCIPI command to the instrument and then immediately reads data from the instrument. As an example, I'm going to do a query on my 34411A instrument with the *IDN command. This SCIPI command returns an identification string from the instrument. Now, I'll do a query with the measure:resistance SCIPI command. This returns a resistance measurement from the instrument. For some instrument buses, such as serial, you might need to add a termination character, such as a /n line feed character, at the end of your SCIPI command to communicate properly. In this section, we will discuss some tips to help troubleshoot if you get unexpected results when communicating with a non-NI instrument. First, double-check any cable connections. Second, verify that the non-NI instruments show up in NIMax successfully. Third, refer to your non-NI instruments manual. You've completed this module. Here is a summary of what you've learned.